Okay, again, this is a question from a standardized test that's from the United Kingdom. It's for high school students, and those high school students are certainly studying trigonometry. I have a question like this over here. We did A, which I thought was a very simple question. We did B, which I thought was a more difficult question, right? It required me to, sort of like remember certain things to do it, all right? But they gave me a good hint, and I took the hint, all right? Now we're on problem C, by the way. It says, hence, that means after I just did this, by the way, I did B, determine according to the model a time after midnight when the depth of the water is 5 meters for the first time. Now someone says, what does that mean? I'm thinking that this function goes up and down, and it's going to hit 5 at some point in time, by the way. Right, going to hit 5 at some point in time. But they want to know the first time it hits the 5, right? Not, it's going to repeatedly hit it, by the way. And it says, give your answer to the nearest minute. Now, this is the part where I have issues with this, right? So I'm going to say, if this is an exam question, you would definitely need to use a calculator for that. At least I believe you need a calculator for that. So it's going to require a calculator. But still, I'm going to go through it as if I didn't have a calculator, and then I'll put my answer down, and then I'll talk about using a calculator to approximate this to the nearest minute, by the way. And that, to me, in my opinion, does require a calculator, or at least tables to look up the values. So what I'm going to do over here, go to the whiteboard and write down what they want, all right? And again, someone says, what did you just do? I found out a simpler equation. I want to point out D was equal to 2 sine x over 3 plus 3 cosine x over 3 plus 6. And they want to know when D is 5 for the first time, by the way. Now, I'm not saying this is a bad equation to use. You could do that. I'm not saying you can't. And you could figure out x by if we want to do that, by the way. But they said, basically I just did C, by the way. So what I want to do is I want to, put down C. And C is has something to do with what we just did, by the way. And so I'm going to say over here, this is okay. You can do that. But we just did something. What did we do? We did D equals 3t squared plus 4t plus 9 over 1 plus t squared, with the understanding that that I got this through substitution, by the way. And again, you have the problem in front of you. You know what the substitution was. The substitution was this over here. And it's going to be the tangent of x over 6. All right? So what I want to do is, I think this might be easier for me to do. It's algebraic in form. Again, this is okay, but I think this is easier. I'm going to try to do this over here. So what do you get? You get 5 plus 5t squared equals 3t squared plus 4t plus 9. That's quadratic. This is going to be 2t squared. How do I do that? I subtract the 3t squared from both sides. Subtract 4t from both sides. Relatively simple. And subtract 9 from both sides, and you get this over here. The next thing I would do is I would divide both sides by 2. And you get t squared minus 2t minus 2 equals 0. And then I start to realize I can't factor using my fingers, which presents somewhat of a problem for me. I can use quadratic formula and say what t is. Twice the coefficient on the square term, which is 2. The opposite of the linear term's coefficient, which is 2, plus or minus. All right? Let's see, that coefficient minus 2 squared, which would be 4, minus 4 times the a, which is 1, the c is minus 2. So that's going to be, 8, which is over here. Let me see if I made a mistake over there. AC is 2, so it's plus 2. All right, you got to be careful. T equals, maybe I should check that again. Minus 2 squared is 4, and 4 times a times c. Let me turn this side. 4, 1, and c is minus 2. Yeah, minus 8, so minus 8 is plus 8. So you get 2 plus or minus 2. Let's see, 4 times 2 is 8. 8 plus 4 is 12. Oh, 12's got a perfect square, doesn't it? So it's going to be 2 plus or minus. The square root of 4 is 2. We get 2 root 3 over 2. Now, I'm not saying it's a nice looking number in the world, but I got this over here. I got 1 plus or minus root 3. Right? 2 divides into both of those terms. Now here's the thinking part. And the thinking part, well, I need x. And I know that t is tangent of x over 6. And this is equal to 1 plus or minus the root of 3. Now I'm going to think, and the way I'm going to think about this is I got two different problems over here. I got the tangent of x over 6 equals 1 plus root 3. The other one I got is an OR problem. I got the tangent of x over 6 equals 1 minus the root of 3. Now, if I thought about this, I need to use the arc function, by the way. And if I did that, I want to point out the tangent function looks like this over here, and the negative ratios are going to give me an angle below 0, but it's going to be an acute angle, by the way. So I'm getting basically two different answers, by the way. So x over 6 would equal the arc tangent of 1 plus root 3. But this keeps repeating itself, by the way. So how often does it repeat itself? Every pi k. And why is that? The cycle length over here is pi. It goes from minus pi over 2 to pi over 2. That's pi. This one's going to be x over 6 equals arc tangent of 1 minus root 3 plus pi k. By the way, I want to solve for x. And what's x going to be equal to? 6 arc, I'm multiplying both sides by 6, by the way, tangent 1 plus root 3 plus, oh, by the way, k is any integer, all right? So it's going to be what? 6 pi k, right? What's this one going to be? X equals 6 arc tangent of 1 minus root 3 plus 6 pi k. Now here comes that part where some students say, what do I do now? Well, if you have a calculator, you can certainly calculate these things, but I'm not going to do that. I'm going to look at this thing over here, and I want to get the smallest possible x, but I want to remind you the x has got to be between 0 and 7 pi. So looking at this one over here, I'm going to say this number over here is going to be a negative number, and then if I'm adding this thing onto it, I'm going to say, that doesn't look like a very good candidate at this point. I'm going to say this one over here is probably going to be the smallest one. Let me put this one down for you. X equals 6 arc tangent 1 plus root 3, all right? K to be 0. So I'm going to say this is where this occurs, by the way. This is where the smallest value of x, I'm just looking at these two over here. This is the smallest value of x between these two numbers that's going to meet the condition where the depth would be 5, all right? What's that, 5 meters? Now, granted, this is where I'd kind of say this is where I'm done. I mean, I really can't get much beyond that. But they did say that I should approximate this. So I'd have to use a calculator to do that. And I did use a calculator, by the way. I did use a calculator. And when I used the calculator, all right, I got this over here. X is approximately, and again, I did use a calculator to do that. 6 times the arctangent of 1 plus root 3 is approximately 7.3195. All right, that's what it approximately is, by the way. Now, what I got to do over here is they want it to the nearest minute, by the way. So I'm going to say the time at which this occurs, this is x, this is the hours after midnight, would be 7. 7 what? It's 7 a.m. But then I got to take this decimal part, and again, I'm using a calculator to do that. I subtract 7 away from this number over here, and I get the decimal. And what do? I multiply that by 60. And then I got to round it off, all right? And what did I get? I got 7:19. And that's 7:19 in the morning, by the way. So I'm going to say a.m. And we're done. Thank you.